Let's suppose we're still working with a rational function given by f of x is equal to p of x divided by q of x. Then, to find the horizontal asymptotes is a little more difficult than finding the vertical asymptotes, because we're going to have three different cases. If the degree of p of x is less than the degree of q of x, then we'll have a horizontal asymptote at y is equal to 0. An example of a horizontal asymptote at y is equal to 0 can be seen below. Note quickly that the graph of a rational function is allowed to pass through a horizontal asymptote, but it's not allowed to pass through a vertical asymptote. The second case occurs when the degree of the numerator is greater than the degree of the denominator by exactly 1. Then our rational function will have a slant asymptote. The slant asymptote is given by the quotient of p of x divided by q of x. An example of a slant asymptote can be seen below. And another thing to note is that if a rational function has a slant asymptote, then it does not have a horizontal asymptote. In other words, a rational function can either have a slant asymptote or a horizontal asymptote, but not both. The last case is when the degree of the numerator is equal to the degree of the denominator. Then we have a horizontal asymptote at the ratio of the leading coefficients. Now let's go ahead and look at a problem where we identify all horizontal, vertical, and slant asymptotes where applicable. We'll go ahead first and find our vertical asymptote, and to do this we need to factor our top polynomial, and we'll go ahead and use the quadratic formula. So again, repeating the quadratic formula, this is going to be equal to a negative b plus or minus the square root of b squared minus 4ac divided by 2a. Filling this in, we'll get 4 plus or minus the square root of 4 squared minus 4 divided by 2. Simplifying this, we see that our x values are going to be equal to 4 plus or minus the square root of 12 divided by 2. Now, this means that the factor of this polynomial here is going to be given by x minus 4 plus the square root of 12 divided by 2, and also x plus 4 plus the square root of 12 divided by 2. And in both of these cases, these factors are not equal to x plus 2, which tells us we don't have a removable discontinuity. Since x plus 2 is not a removable discontinuity, it doesn't correspond to a removable discontinuity, then it must correspond to a vertical asymptote. We'll have a vertical asymptote then at x is equal to negative 2. Now, the degree of the bottom is exactly 1 less than the degree of the top. This tells us we're not going to have a horizontal asymptote. We're going to have a vertical one. A slant one. So to find the slant asymptote, we're going to go ahead and divide our x squared minus 4x plus 1 by x plus 2. So we'll go ahead and do this on a new page. Starting our division algorithm, we'll need an x up top, and so we'll get an x squared plus 2x. Multiply this by negative 1 and add it. Our x squareds disappear, and we're left with a negative 6. X, pull down our plus 1, and then subtract by a negative 6. This will give us a negative 6 minus 12. Multiply by a negative 1. Our 6 x's cancel out, and we're left with a 13. So therefore, we'll have a slant asymptote at y is equal to an x minus 6. Let's go ahead and identify all horizontal and slant asymptotes of the following rational function. This time we're only looking for the horizontal and slant asymptotes, and remember that it's only going to have one or the other. And what we see is the degree of the top function, so the numerator, is actually equal to the degree of the denominator, q of x. And this tells us we're going to have a horizontal asymptote at y is equal to the leading terms, so ap divided by bq. Here we see we have a leading term 6 up top and a leading term of 2 on the bottom. So our horizontal asymptote is going to be given by y is equal to a 6 divided by 2, which is just equal to 3. And again, since this has a horizontal asymptote, there is no slant asymptote. Let's look at one more problem where we find all the x and y intercepts and the asymptotes of a given rational function. To find the x-intercepts, we set y equal to 0 and solve for our x's. Here, we have 0 is equal to x minus 2 times x plus 3 divided by x minus 1 times x plus 2 times x minus 5. Multiplying both sides by the denominator, this becomes 0 is equal to an x minus 2 times an x plus 3. And this tells us we'll have an x-intercept when x is equal to 2 and another one when x is equal to negative 3. Writing this as points on our graph, we'll have 2, 0 and negative 3, 0. Now to find the y-intercepts, set the x equal to 0 and solve for y. Here we'll get y is equal to a negative 2 times 3 divided by negative 1 times 2 times a negative 5. Simplifying this, we'll get that this is just equal to negative 3 divided by 5. Writing this as a point on the graph, our y-intercept will be given by 0, negative 3 divided by 5. Now we want to go ahead and find the asymptotes. So let's go ahead and copy our rational function. And the first thing to notice is there's no common factors between the numerator and the denominator. This means the factors on the bottom are all going to correspond to vertical asymptotes. So we'll have a vertical asymptote at x is equal to 1, we'll have another one at x is equal to a negative 2, and we'll have the last one at x is equal to 5. And we need to decide whether we have a horizontal or a slant asymptote. And to do that, we check the degree of the numerator versus the degree of the denominator. So the degree of our p of x is equal to 2, and the degree of q of x is equal to 3. And so this number 1 implies that there's no slant asymptote. And since the degree of the numerator is less than the degree of the denominator, we'll have a horizontal asymptote at y is equal to 0.